So this section, it's the last section in chapter 6, and it's called Fitting Exponential Models to Data. And we'll talk about what more of that means in a little bit. The idea is, we don't just have these formulas necessarily all the time just out there in the world. Sometimes we have to go and we have to get data to form a model. And so the idea is you get a bunch of data points. You go out and you observe them in the real world. So you get real world data, and then you're going to graph those as data points. So you graph those points. So there'll be two variables, an x and a y, however your variables are going, but you graph those points, and then you look at what the best model would be. You're saying, what does this look like? Does it look like a linear curve, an exponential curve, a logistic curve? Look at what the curve looks like. That's not written very well, but you're trying to see what that curve looks like. It won't be exact, okay? I want to point that out. You're just getting kind of like, okay, well, what do the points kind of do? And you're looking for the best model, okay? We do this we want to get a model so that we could predict future events, okay? So you say, well, this is what the trend is doing. This is what it looks like. So we're going to say, we think this is going to happen in the future. And that allows us to prepare for things. So if you're planning like a city and you're recognizing how a population is growing, you say, well, okay, in 10 years we're going to need so many schools and so many hospitals, and you can predict, and prepare for things that are coming. Okay, sometimes they use the word function, equation, and model, those three words, interchangeably. They each have their own definition. When we're talking about a model here, we're talking about something that's approximate to model real world situations. Okay, so we're looking for a model that would approximately represent these real world situations. Okay, so all that stuff that I wrote was regression analysis. I didn't write it underneath for some reason. Okay, we're looking in this section at 3 exponential models. An exponential model, and exponential models are going to either go like this, where they're increasing, and I think we've looked at this before, or like this, where they're decreasing. Something like that type of curve. A logarithmic model could be something like this, where you have an asymptote there. Or it could be the other way, going like this. And so those are pictures of, okay, well, if you get your data points and they're looking like a curve like that, you'd say, oh, it's going to be an exponential growth model and that type of thing. The logistic model, that's the kind where it kind of starts out increasing, but then it starts to level off. And then get that asymptote there somewhere. It looks like there's a carrying capacity, a limit to what you could get. All right, so those are the 3 we're going to look at. The rest of this section, we have 3 examples. That's all there is. It's a pretty short section. And it's based on, in the textbook, they're basing it on your being able to create the model if you have a graphing calculator. You're not required to have a graphing calculator for this course, so I'm going to give you the equations. What I really am interested in you being able to do is to graph the data, recognize which type of model it would be, and then use the model once it's given to you. Okay, so just a heads up on that.